Bismillah ar-Rahman ar-Rahim. This is teacher Iman al-Khaldi explaining how to write a quadratic equation from its roots. That's mean the roots or the solutions are given and we need to construct or to form a quadratic equation, including in complex number z square minus their sum multiplied by z plus their product of the roots, and that all equal to 0. Or in symbols, we can say that the quadratic equation started by z square minus z1 plus z2 times z plus z1 times z2 equals to 0. Be sure that you will have negative here in the middle and positive at the last and equal to 0, where z1 and z2 are two given roots or solutions. We have some formulas can be used to make your work easier if you want to form a quadratic equation with real coefficient. So this is a special case including real coefficients. That means z1 and z2 must be conjugated, and z1 and z2 are the two roots. Conjugated means they have different signs in the imaginary part, and in this case we can remember how to multiply them and add them. So try to remember that z1 plus z2, if they are conjugate, will give you 2 times the real part. And if you're going to multiply z1 times z2, and they are conjugates, you will get the real part all squared plus the imaginary part all squared. And you can see this here exactly. Z squared minus 2 times the real part multiplied by z plus real part squared plus imaginary part squared all equal to 0. Or in symbols you can write z squared because it is in complex number minus always, and take care about this minus 2a times z plus a squared plus b squared equals 0. Or you can use x and y, where a and b are the real and imaginary parts of the root z1 or z2 respectively. We can now have some exercise, and the first exercise is talking about right true for the true statement and false for the false one. In the first question, the equation whose roots are given, which are 3i and 3 over I, is z squared minus 9 equal to 0. You can use the general rule, which is z squared minus z1 plus z2 in a bracket multiplied by z plus z1 times z2 all equals to 0. And think about z1. z1 is 3i and z2 is 3 over I. After moving this I from down to up, you can change it to be negative 3i. They are pure imaginary and conjugates. So you can deal with the second rule if you would like to, which is z squared minus 2az plus a squared plus b squared if you would like to. And a will be 0, but b will be 3. And if you want to find the general one, it is easy for you. Z squared minus 3i plus minus 3i for the conjugate, and then a plus 3i times negative 3i. That all should be equal to 0. If you add them, you can say that these are different signs and the sum of them will be 0. And if you multiply them, you can get 3 times 3 is 9, with negative is negative 9, and this I with this I will make it I squared. So you can get negative again. Negative by negative is positive later on. So the last answer is going to be z square like this plus 9 equal to 0. If you compare your answer with the answer which is given in the question, you can see they are different. So that will make it false. So this statement is false. But if you would like to use the rule which is written here, z squared minus 2a, it works also. But I will give you another way to solve it easily by making this rule. Here, if you have, and let's make it as a note, if you have the first complex number, which is the reverse root, equals to bi, and the second root is going to be negative bi. They are pure imaginary with different signs, and they are also conjugates. Or we can say that their sum will be 0 and their multiplication will be positive b squared. So the equation will be easily like this: z squared plus b squared equals to 0. And that what shall we do here if we are going to use this rule? We are going to say that since z1 is 3i and z2 is negative 3i and they are conjugates, that will make our equation as z squared plus 9 equal to 0. And this is an easy way. And number 2, the equation with real coefficient, and you have to focus on the word real coefficient, whose one of the roots is 2 minus 3i is z squared plus 4z plus 13 equal to 0. Let's focus on the word with real coefficients, and that can help you to go to this box and try to have this rule, which is z squared minus 2az plus a squared plus b squared equal to 0, because the two roots are conjugates. So I can write here the two roots are conjugates, and that can help you to use it easily. So here z squared minus in a bracket 2 times the real part multiplied by z plus the imaginary part, which is a squared plus b squared with the imaginary part squared plus the real part squared, all will be in the constant term equals to 0. In the given root, we can see that a is going to be 2 and b is going to be negative 3. Let's use it. Z squared minus 2 times 2, which is 4z, and here plus a squared, which is 2 squared, which is 4, plus b squared means 9. Add them together, you will get 13. So the equation is going to be, after simplifying your work, z squared minus 4z plus 13 equals to 0, which is going to be different in sign by the middle term, and here it's negative here and here positive, and that will make it false again. In number 1, in choose the best alternative, you can read f 2 minus 3i is one of the roots of a quadratic equation with real coefficients. Then the other root is, other root by the word real coefficient should be conjugates. Conjugates. So that will change the middle sign or the imaginary part, and that will make 2 as it is, but with plus 3i, and that will be the third choice, like this: 2 plus 3i. Let's go to the next question, which is 2. The quadratic equation again with real coefficient. Let's focus on the word real coefficients, where one of the roots is 3 minus I is. So I can go back to this equation again, which is z squared minus 2a, and try to use it. Z squared minus 2a times z plus a squared plus b squared all equal to 0. He give you one of the roots, so you can get from it a and b. A here is 3 and b here is negative 1. Use them later in the equation. So here 2 times 3 is 6 times z plus 3 squared plus negative 1 all is squared, close your bracket, equal to 0. So your equation now is ready. It is z squared minus 6z plus 9 plus 1 is 10, and that all equals to 0. You can find your answer at the fourth alternative, which is z squared minus 6z plus 10 equals to 0. In question number 3, you can have the quadratic equation with real coefficient again. So real coefficients means you are going to focus on the conjugates, where one of the roots is 2i minus 3. So you have the value for a, which is negative 3, and try to focus on what he give you, because he make a switch between them, so you may get confused. This is a and this is b, which gonna be equals to 2. Try to write the rule of the quadratic equation, which is z squared minus 2 times az, and that all plus a squared plus b squared, all equals to 0. Z squared minus 2 times negative 3, that will make it negative 6 times z, plus a is negative 3 all squared plus 2 all squared, close your bracket, equal to 0. Try to simplify your work. You can write z squared plus 6z and then plus 9 plus 4. That will make it 13 equals to 0. And your answer gonna be also the fourth, easily. And the fourth is including the best alternative. In number 4, the quadratic equation with real coefficient again, and let's focus on the word real coefficients and say they are conjugates. You can write this beside it when you are in the exam. Conjugates, where one of the roots is given by 2 and pi over 2, which is in polar form. I can change it to algebraic easily to be 2i, because it lies on the imaginary positive axis. And that means if one of them is 2i, so this is z1, and z2 will be equals to negative 2i. So I can apply this rule, which is saying here, if you have z equals bi and z equals minus pi, then if they are imaginary and conjugates, then z squared plus b squared will give you 0. So I can use now this rule to say z1 equals 2i and z2 equals negative 2i. They are imaginary and pure, and they are conjugates. So that will make it z squared plus 4 equals to 0, which gonna be the second exactly. In number 5, the quadratic equation with real coefficients again, where one of the roots is written as 3 pi over 4 as. This can be easily translated to be in algebraic form by using this rule. 2 outside multiplied by cosine 3 pi over 4 plus I sine 3 pi over 4. And you can know that this pi over 4 is 45. If it is multiplied by 3, that will make it 135. So you are dealing with an angle in the second quadrant, which is 135 degrees. And here sine 135 degrees. 135, it is in the second quadrant, and that means it has negative sign for cosine and positive for sine. And it is from the family of 45, because 180 minus 135 in the second will be 45. So you can change this to be 2 bracket negative cosine 45 degrees plus I sine 45 degrees. And that will be easily written as 2 times negative root of 2 over 2 and plus 1 over root of 2i. Then you can let this 2 get in and cancel it with this 2 inside. So you can cancel this 2 with this 2, and you can get negative root of 2 plus root of 2 over 2 is written to be cancelled, 2 with a 2 to get you plus root of 2i. And that will be easier for you if you want to deal with this complex number in algebraic form. Now, he told you to find the quadratic equation with real coefficients. This means I will use the rule of z squared minus 2a, all multiplied by z plus a squared plus b squared equals to 0. Z squared as it is minus 2 times root of 2 with the negative sign, and that will make it positive, with a z finally, plus a squared, that's mean negative root of z, if you root of 2, if you square it, you can get 2 plus b is root of 2 also, if you square it, you can get 2. And these together will give you 4. So the equation is z squared plus 2 root of 2z plus 4 equals to 0, which is going to be alternative number 4. Z squared plus 2 root of 2z plus 4. Number 6, the quadratic equation, whose roots are 3 plus 2i and 1 minus 2i is going to be, they are not conjugates or anything. So they are different completely, but they are complex numbers. So we are going to deal with the general rule of forming quadratic equation. z1 is equals to 3 plus 2i and z2 equals 1 minus 2i. I can add them first, z1 plus z2 by adding reals together and imaginary together. So here this will give you 4 and imaginary will give you 0. So you will get 4, and you can multiply them. z1 times z2 will give you a bracket including 3 plus 2i times 1 minus 2i. Let's multiply algebraically the first with the first, and the first with the second with the first, the second with the second. 3 times 1 will give you 3. 3 times negative 2i will give you negative 6i. Then 2i times 1 is plus 2i, then minus 2 by 2 is 4i by I squared, and that will make it negative. So you can add now reals together and imaginary together. 3 plus 4 is going to be 7, and imaginary, which are here negative 6 plus 2, and that will give you negative 4i. Negative 4i. This will be our multiplication or product and summation. Let's use this general, which is z squared minus always with z1 plus z2, close your bracket and multiply by z plus z1 times z2 equals to 0. Z squared is here minus their sum is given, which is 4z, plus their product is 7 minus 4i equals to 0. You can focus on the all alternatives. You can't find this answer till you can move this negative 4 to the other side, and that will change it to be positive. And you can get z squared minus 4z plus 7 equals 4i, and that will make it this alternative, which is the first. Thank you very much. Good luck.